Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think yesterday we were discussing about the synthesis of diethyl malonate or malonic ester starting with alpha halo ester, and as well as we have discussed some of the application of it. So today what we are going to discuss, rest of the application of that malonic ester. So let us see here second application, this one, synthesis of butanoic acid using DEM or malonic ester. This will be the second application. What we required here required to draw the correct structure of the target molecules. Target molecule is a butanoic acid, because they already given us the final product, end product as well as starting material, and you have to use the suitable reagent, appropriate reagent, and maintaining the proper reaction condition. You have to achieve the target molecule. That's the thing. And now what is the first point required here? First, to draw the correct structure of butanoic acid. OIC acid indicate that there is a carboxylic group is present, but indicate that there are the 4 carbon atom in the straight chain. So let us see. Draw one carbon atom here, another one, and this third one. Now we know that OIC acid carboxylic group is always present at the end of the carbon chain. So here I am showing that carboxylic group. Now carboxylic group always has number 1. So you can give the number 1, 2, 3 and 4. So 4 carbon atom. Now attach the carbon atom with appropriate hydrogen atom. 1 bond is there. So you can attach here 3 hydrogen atom, CH3 methyl group. Here 2 bond is already there. So you can attach CH2 here. Here 2 bond is there, and so you attach the CH2. So this is the structure of butanoic acid. For sake of convenience, I am writing one of the hydrogen atom this way or this fashion. So now what is the next point? Next required is the planning. Planning, you do the planning properly so that the rest of the work becomes easy. So first point here. So here I am highlighting this part of the molecule with the square bracket CH, double bond OH. CH, double bond OH. This part is coming from this part is coming from DEM. DEM is diethyl malonate or malonic ester. Now second point, see here, this is a CH3 CH2 group, means this CH2 CH3 group, this is a ethyl group. This part is coming from This part is coming from primary alkyl halide. Primary alkyl halide, that is, you can use CH3, CH2 and Br, ethyl bromide. And this is our planning. After the proper planning, the next point will be synthesis. During the synthesis, here what is required, they have provided us the starting material, which is DEM or malonic ester. See here the structure of malonic ester. As we know that the structure of malonic ester will be ETO, then C double bond O, then CH2, C double bond O, OET. This will be the structure of, this is the structure of DEM diethyl malonate, and it will be treated with, usually we are using the base like sodium ethoxide, which is a base which can abstract the highly acidic proton. Here methylene proton are highly acidic in nature, and therefore we are going to get here ETO, C double bond O, CH minus, then C double bond O, OET. The negative charge present on carbon atom, that species is known as a carbanion. And after that carbanion, this structure, same structure, I am taking here ETO, C double bond O, CH minus, C double bond O, OET. Then second step, usually we are using the appropriate, here this one CS3, CH2, Br, that is the ethyl bromide. So that negative charge is going to attack on the CH2. There is a departure of Br, and we will be getting here ETO, then C double bond O, then CH, then CH2, CH3, ethyl group I am writing here at the bottom, then C double bond O, OET. That's it. And this process is known as alkylation. We treated this carbanion with primary alkyl halide, undergoes nucleophilic substitution reaction, resulting compound formed as a alpha substituted diethyl ester or diethyl malonate. And now the next point, the next step as usual is this one, H2O in presence of H plus. This process is known as hydrolysis. Hydrolysis is the process used to convert ester group into acid, and we will get here HO, then C double bond O, CH, CH2, CH3, C double bond O, OH. This is the compound which we got over here. And after that there is another step which we are normally employing is heated. There is a evolution of carbon dioxide. This process is known as decarboxylation. Decarboxylation, this is a process taking place, and as we know that how it takes place, this sigma bond form as a double bond over here. There is a double bond revolving around it, and there is a sigma bond making this carbon atom negative, and we will be getting here HO, C double bond O, then CH minus, then CH2, then CH3. That is the intermediate which we are getting, and that intermediate further treated with H2O in presence of H plus, and now see this and this and this same is there, but that process is known as a hydrolysis, and here this process is known as a protonation. During the work of proton comes over here, and you will be getting the, I am writing as a this structure in a proper way, CH2, then CH2C double bond O and OH, and this is nothing but our starting material, this is our target molecule. Target molecule means whose synthesis is being planned is called as a target molecule. This will be the second application of diethyl malonate or the malonic ester. Now let us discuss the next application, that is application number 3 over here. So now here just I am making the correction in the third application. As usual here synthesis of, here I am writing the pentanoic acid. Pentanoic acid using diethyl malonate or malonic ester, or other way round you can say synthesis of pentanoic acid from diethyl malonate or malonic ester. And here what is required first point required to draw the correct structure of the given target molecule pentanoic acid, and as usual you know that pent indicate as there are 5 carbon atom in the straight chain. So draw the 5 carbon atom in the straight chain, and as we know that OIC acid means there is a carboxylic group, and that carboxylic group is always present at the end of the carbon chain, and I am showing that carboxylic group like this, and the rest of the carbon atom you should attach appropriate hydrogen atom. Here you can attach 3 hydrogen atom because one bond is there, carbon has a 4 valency, to satisfy 4 valency, so you should attach the carbon atom with appropriate hydrogen atom. 2 bond is there, so you can attach 2 hydrogen here already 2 bond, here also you can attach CH2, here 2 bond is there, so you can attach 2 hydrogen, here already 4 bond is there, so there is no need to attach any hydrogen atom. Remember that 1, 2, 3 and 4 is there. So this is nothing but our target molecule, and the numbering are here 1, 2, 3, 4 and 5, and that's why pentanoic acid. Now here I am making one of the hydrogen atom, I am representing one of the hydrogen atom like this. So now the next point is the planning. Do the proper planning here. Planning. In the planning, as usual, we are mentioning 2 or 3 points depending upon the requirement of the starting material. So here the first point which I am making over here, and see here I am highlighting this part of the organic compound CH double bond OH, means this one CH double bond OH. This part is coming from DEM. DEM means, as we know, that diethyl malonate. Then second point, this is the first point, and this will be the second point. Now I am highlighting this part also here. So what is that? This one, CH3 CH2. This part is coming from, once again, this part is coming from primary alkyl halide. This part is coming from primary alkyl halide, that is CH3, CH2, CH2 and the Br, right? Now what is the next usual point to study? Usual point or the normal point is a synthesis. This is a usual way of doing this or justifying this application. Synthesis you can start from the starting material or the precursor is given here. That is a diethyl malonate. You know the structure of diethyl malonate. ETO, C double bond O, then CH2, C double bond O, OET. This is a structure of diethyl malonate, and this structure will be treated with what? It is treated with, as usual, we are normally using the base NaOET, sodium ethoxide. What it will do? It will abstract the more acidic proton which is available on methylene. So we will be getting here this one, intermediate ETO, C double bond O, then CH minus, then C double bond O, OET. The negative charge present on the carbon atom, that species generally termed as carbanion, and that carbanions are well stabilized due to the resonance or the mesomeric structure. Now I am writing these structures as it is ETO, then C double bond O, CH minus, C double bond O, OET, and after that I am adding the appropriate product CH3, CH2, appropriate reagent CH3, CH2, CH2 Br, and this process is known as a alkylation. And now this negative charge can attack on this CH2, and you will be getting here ETO, C double bond O, then CH, then I am writing that ethyl group for suitability. Neatly I am writing here CH2, then CH2, CH3, C double bond O, OET. After that, let us see the next point which we are discussing over here, this one. Now this is a structure which we got over here. After alpha substituted dim diethyl malonate or the malonic ester, the next step, usually we are using H2O in presence of H plus. This is one of the step. This step is known as hydrolysis. This is known as a hydrolysis. Hydrolysis is a process where ester group is get converted into acid, and you will get here HO, C double bond O, CH, then CH2, CH2, CH3, C double bond O, OH. This is the diethyl acid we are getting, and the next step usually we are using, that is a symbol of heating. Then there will be a evolution of carbon dioxide. Once carbon dioxide get evolved, and how it get evolved, that I am showing over here, so you can see properly. And now after that we are getting here HO, then CH minus charge, and this propyl group I am writing like this, CH2 and this CH3, and sorry, here HO, then C double bond O, this one 1 2 3 4 and 5, and now the next step will be this one, H2O in presence of the H plus, and now H2O in presence of H plus, this step is known as protonation. In the protonation, what is happening? This intermediate will pick up the proton to get the stable final product, and that final product I am writing over here, CH3, then CH2, C double bond O and OH. This is the compound which we got over here. See, this is our target molecule. We can say how do we get this compound that is shown over there. It is a propanonic acid. So this is application number 3 which we have seen over here. Now let us move on to the next application, that is application number 4, which we are going to discuss shortly. Before that, let me clean the board first, this one, so that only the application number 5 now. So just I am here, synthesis of hexanoic acid. See there. Now you are familiar with this structure. The steps are regularly same. We are facilitating this reaction by using the step by step sequential step, and we are achieving our target molecule. Here the final product or the target molecule is given. What you need first, you need to draw the correct structure of the given target molecule. The given target molecule is hexanoic acid. Now tell me, hex indicate that there are 6 carbon atoms are there. You can draw in the straight chain 1, 2, 3, 4, 5 and 6. See here, 1, 2, 3, 4, 5 and 6. There are 6. And now OIC acid suffix indicate that there is a carboxylic group is present, and that carboxylic group is always present at the end of the carbon chain, and which I have shown here, C double bond OH. Then numbering you should start in a such a way that the carboxylic group should get the first number, and here 1, 2, 3, 4, 5 and 6 and you can attach the appropriate hydrogen atom. You can attach here CH3 because terminal carbon atom always possess the 3 hydrogen atom, and here middle one they are always possess the CH2. This also possess CH2. This also possess 2 hydrogen atom. This also possess 2 hydrogen atom, and this carbon which has carbonyl group, hydroxyl group and here CH2 group means it satisfies its all valencies, and therefore it does not require to attach any, there is no hydrogen atom attached to that carboxylic group. Now the next point usually is a planning. Do the proper planning, and as usual we are writing as a 2 point. Now is a point number 1. here once again I am showing this organic compound this way, and I am highlighting this part of the hexanoic acid like this, and here CH, C double bond O and OH. This part, highlighted part of this target molecule is coming from, this part is coming from, this part is coming from, this part is coming from DEM. DEM means diethyl malonate or malonic ester. Second point which I am mentioning here, as look at, I am again highlighting this part, see here, and this part, and now this part is coming from what? This CH2, then CH2, CH2 and CH3. This part is coming from this butyl part, N-butyl part. This part of the organic molecule is coming from primary alkyl halide, that is this one, CH3, CH2, CH2, CH2 and Br 1-bromobutane, or you can say butyl bromide. Now after the planning you require synthesis. So do the proper synthesis in a systematic way. Synthesis. In the synthesis they have provided us the starting material, which is DEM, diethyl malonate, and you know the structure of diethyl malonate is this one, O, then CH2, C double bond O, OET. The first step is as usual. What is that? You treat this compound with the reagent NaO2, NaOET means sodium ethoxide, and sodium ethoxide is a base, it is a base catalyzed reaction. This base can abstract this acidic proton ETO, then C double bond O, then CH minus C double bond O, OET. Once it form as a carbanion, that carbanion can be stabilized by resonance effect or mesomeric effect, and when now in this structure it is present on the carbon atom, that species is known as a carbanion. When it goes into as a this double headed arrow is a resonating structure, this can negative charge can be negative charge goes on oxygen atom, because oxygen atom is more electronegative than the carbon atom, and therefore you will get here ETO CO minus double bond CH, then I am writing C double bond O, then OET like this. So this species is no, when negative charge present on oxygen atom near the carbon-carbon double bond, that species is known as a enolate, and these are in a given case the negative charge present on oxygen atom as well as on a carbon atom, such reagents are known as ambident reagent. Ambident reagent, as we know that the negative charge are present on two different atoms. In this particular case, in one case it is present on carbon atom, in another case it is present on oxygen atom, and therefore this type of the reagent are called as ambident reagent. I am taking this structure once again: ETO, C double bond O, CH minus, then C double bond O, OET. It will be further treated with this one, CH3, CH2, CH2, CH2 and Br. There are 4 carbon atoms. Why I am taking as a 4 carbon atoms? So that we can make our starting material by using this one. It is going to attack on this CH2. There is a departure of Br, and then we will finish this one very shortly. ETO, C double bond O, CH, then CH2, 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 CH3, C double bond O, OET. And now finally what we are going to get here, once you got as a ester, the next step will be H2O in presence of H plus. This process is known as a hydrolysis. Hydrolysis, what happen? Ester group get converted into as a acid, then CH, CH2, 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 CH3, then C double bond O, OH, and after that heat it, there is a evolution of carbon dioxide like this, and you will be getting here HO, C double bond O, CH minus CH2, CH2, then CH2, CH3, 1, 2, 3, 4, and after that do the add this step, as we know that this is protonation. After the protonation we will be getting the final product is this one. I am writing in a proper way: CH3, CH2, 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 then CH2, 1, 2, 3, 4, 5, and C double bond O, OET, OH. This is nothing but our starting compound, final product, that is the hexanoic acid. So in this way we have completed our application number 4. So remaining application we will discuss in our next lecture. Till then, have a nice day. Thank you.